Imagine waking up one morning, stretching your arms, yawning, and realizing that your star, our dear sun, has decided to double in size overnight. Well, good morning to the apocalypse, my friends. Hello, I'm Albert Einstein. You know, the guy whose hair looked like it survived a solar explosion every day. And today, I have a question for you. What if our sun suddenly became twice as big? Now, before you panic and start digging a bunker in your backyard, let's clarify what twice as big really means. Are we talking about the sun's diameter becoming 2 times larger? That would make it a swollen monster, but with the same mass, just more bloated, like your uncle after Thanksgiving dinner. Or do we mean that the sun's mass doubles? Now that is a very different nightmare. Twice the mass means twice the gravitational pull. Planets would dance around it like terrified moths circling a blazing bonfire, and probably get burned just as quickly. So today, let's embark on this cosmic thought experiment. First, we'll dive into the true scale of our sun, a star so huge that it could fit 1.3 million Earths inside it, and that's before it even considers doubling up for breakfast. Then, we'll separate the 2 terrifying scenarios. Scenario 1, double the diameter, same mass. Scenario 2, double the mass, same diameter, or even smaller and denser. Both would dramatically change everything we know about our solar system. And yes, your sunscreen won't help. Ready to unravel the chaos? Let's begin with understanding the real scale of our mighty sun, before we decide to mess with its size like a toddler smashing Play-Doh. So now that we've established that the sun could either become a bloated balloon or a dense fiery demon, let's talk about what actually happens inside this star when it decides to change size. First, let's imagine the scenario where the sun's diameter doubles but its mass remains the same. Sounds impressive, right? Twice as big in size, but with the same weight. Kind of like inflating a beach ball. It looks massive, but try sitting on it and you'll realize it's just full of hot air. In this case, the sun would become cooler on the outside because its energy is now spread across a much larger surface area. It would puff up into what astronomers call a subgiant, or even a red giant, depending on how far this expansion goes. Its outer layers would swell and cool, giving it that reddish, ominous glow you see in dying stars. But don't be fooled by its pretty colors. Inside, the core remains the boss. It continues its nuclear fusion of hydrogen into helium, but the balance of forces shifts. Gravity still tries to crush the star inward, while radiation pressure pushes outward. In a swollen sun, the outer layers become less dense, making the star's structure more unstable. Essentially, it becomes a star going through a midlife crisis, growing a giant fiery belly it doesn't know how to handle. Now, Scenario 2. This one is my personal favorite for purely evil scientist reasons. If the sun's mass doubles, we're talking about serious business. Twice the mass means the gravitational force compressing the core would increase dramatically. And what happens when you squeeze a star's core? The temperature skyrockets. Currently, the sun's core temperature is around 15 million degrees Celsius, but with double the mass, that temperature could rise to over 25 million degrees, maybe even 30 million. At these temperatures, hydrogen fusion occurs at a much faster rate, meaning the sun would burn through its fuel like a Formula One car burning through tires on race day. This hypercharged fusion process would release far more energy, increasing the sun's luminosity exponentially. So while you're out there worrying about sunburns, just know that Earth would be fried like a piece of bacon left on the frying pan for too long. But wait, it gets even better. A massive increase in fusion rate doesn't just mean more light and heat. It means the sun's life expectancy shortens drastically. Our current sun has about 5 billion years left before it turns into a red giant and eventually a white dwarf. But with twice the mass, it could end its life in just 1 billion years, or even less, becoming a red giant much earlier and swallowing the inner planets, including poor Mercury, Venus, and probably Earth too. And here's another cheerful fact. If it becomes massive enough, the endgame could be even more dramatic. Instead of peacefully shrinking into a white dwarf, it could explode in a catastrophic supernova, scattering its guts across the galaxy. Boom! Instant nebula decoration for the Milky Way. In short, whether our sun bloats up or doubles its mass, the changes in temperature, density, and fusion processes would transform it into a completely different star. Its identity crisis would have devastating consequences for every planet orbiting it. So next time you think your life is chaotic, just remember, at least you're not a star balancing gravitational collapse and thermonuclear explosions every single second. Let's continue our journey to see what these changes mean for our solar system and for the fragile blue dot we call home. So, what happens to the rest of the solar system when our beloved sun decides to throw a tantrum and double in size or mass? Let's start with the first scenario. The sun doubles its diameter but keeps the same mass. Now, in cosmic terms, this is like putting on a giant fluffy coat. You look bigger, but you're not heavier. Gravity doesn't change, because gravity depends on mass, not size. So in this case, the orbits of the planets remain more or less the same. Sounds comforting, doesn't it? Well, don't relax just yet. Even if gravity stays the same, the sun's swollen outer layers could reach out and engulf the innermost planets. Mercury would be the first to go, vanishing into the sun's extended atmosphere like a mosquito flying into a flame. Venus, well, poor Venus would probably get swallowed too. And Earth? It depends on just how far the sun decides to puff itself up. Some models suggest we might just narrowly escape being absorbed, only to be roasted by the intense heat as our oceans boil away and the ground turns into molten rock. Basically, either way, don't plan any summer beach trips. Now, let's consider the more dramatic scenario. The sun doubles its mass. This is where the real fun begins, if your definition of fun includes cosmic destruction. Twice the mass means twice the gravitational pull. Suddenly, the sun's grip on its planet strengthens like an overenthusiastic dance partner who won't let go. Orbital velocities increase, and each planet is pulled closer to the sun to maintain orbital balance. Mercury and Venus wouldn't stand a chance. Their orbits would shrink so dramatically that they would almost immediately spiral into the sun, burning up long before they reached its blazing surface. But what about Earth? Our comfortable little orbit at roughly 150 million kilometers from the sun would no longer be stable. We'd be dragged inward to a tighter, faster orbit, making our year shorter. Sounds convenient for birthday celebrations, doesn't it? Unfortunately, it comes with a minor downside. Temperatures would soar far beyond survivable levels. Forget global warming. This is cosmic incineration. And for Mars, our favorite candidate for colonization, it too would be pulled closer. And although it might briefly enter the so-called habitable zone, the entire definition of habitable becomes irrelevant when your star is bombarding you with lethal radiation levels. In short, if Earth doesn't burn, it will be sterilized. Beyond Mars, the outer planets would also shift inward slightly, but with less catastrophic results. Jupiter and Saturn might actually thrive under a slightly warmer environment, their thick atmospheres glowing even more ominously under the intensified sunlight. But don't expect to set up a vacation resort there. Their surface gravity would still crush you like an ant under a steamroller. And what about Pluto, you ask? Well, Pluto would continue doing whatever Pluto does, far away and feeling excluded from the drama as always. At least someone gets a break. But perhaps the most shocking consequence is that, with the sun's increased mass, the entire balance of the solar system changes. The delicate gravitational dance between planets becomes chaotic. Orbital resonances that kept asteroids in check might be disrupted, sending showers of them towards the inner planets. Picture this: Earth, already burning under an angry sun, pelted by flaming asteroids. A cosmic horror show with no escape. So, to sum it up, doubling the sun's diameter turns it into a giant puffball that might swallow its inner planets. Doubling its mass transforms it into a deadly gravitational tyrant, pulling its children closer to their fiery doom. Isn't astrophysics just so wonderfully terrifying? But hold on to your thoughts, because next, we'll explore exactly what these changes mean for life on Earth, assuming anything remains to witness it. Now, my dear friends, let's talk about the part that really hits close to home. Quite literally, what happens to life on Earth when the sun decides to become twice as big or twice as massive? Let's begin with the swollen sun scenario. It doubles its diameter, but keeps the same mass. Sounds like it just wants to impress other stars with its new figure. Unfortunately for us, that impressive figure comes at a deadly price. As the sun swells into a red giant or subgiant, its luminosity actually increases, despite its outer temperature dropping slightly. Why? Because its gigantic surface area radiates far more total energy into space. For Earth, this means that temperatures would rise drastically. The heat from our newly expanded star would begin boiling away the oceans, turning our beautiful blue planet into a steamy, suffocating sauna. Water vapor, as you know, is a greenhouse gas, so this would further trap heat, spiraling into an unstoppable global meltdown. Imagine every ocean on Earth evaporating into the atmosphere, creating dense, hot clouds that eventually break down under intense solar radiation. The water molecules themselves would be split into hydrogen and oxygen by ultraviolet light, with the hydrogen escaping into space forever. Goodbye oceans, goodbye rain, goodbye life as we know it. Now, if the sun's mass doubles instead, oh, brace yourself. In this scenario, not only would we be pulled into a tighter orbit, but the sun's luminosity would increase exponentially due to the rapid acceleration of nuclear fusion in its core. We're not just talking about a hotter sun. We're talking about a sun so intense that its radiation levels would make Earth's surface completely uninhabitable within days. Temperatures would rise so fast that all life on land would perish almost instantly. Forests would ignite into global firestorms. Oceans would begin boiling off at alarming rates, and the atmosphere itself would become thick with steam and toxic gases. Essentially, Earth would transform into a planetary-scale pressure cooker. And it's not just heat we should worry about. The sun's increase in ultraviolet and high-energy radiation would strip away parts of our atmosphere, destroying the ozone layer completely. With no ozone to protect us, the sun's rays would bombard the surface with lethal doses of UV radiation. Even microscopic life forms, the tough little bacteria that survive everywhere, would struggle to endure this onslaught. But could life survive underground? Well, theoretically, yes. Deep beneath the surface, away from deadly radiation and extreme heat, microbial life could cling on for a while. There are bacteria living kilometers below Earth's crust right now, feeding off minerals and chemical energy rather than sunlight. They might become the last living witnesses to Earth's former glory, if they care about such philosophical matters, which I doubt. And what about underwater life? Unfortunately, with oceans boiling away into the sky, aquatic creatures wouldn't stand a chance. Only deep-sea organisms living near hydrothermal vents might survive for a short period, until the oceans completely evaporate or heat reaches even those abyssal depths. So, in short, whether our sun becomes a bloated red giant or a heavier, hotter star, the result for Earth's biosphere is catastrophic. Total extinction on the surface is inevitable. Life underground might survive temporarily, but eventually, as the heat continues to rise, and Earth's environment becomes more hostile than Venus, even the hardiest extremophiles will perish. If this sounds depressing, don't worry. You still have a few billion years before the sun naturally does this on its own. Until then, enjoy your coffee, walk your dog, and remember, at least you're not being incinerated by a star having an identity crisis. In our next segment, we'll explore the long-term fate of the sun and the solar system after such dramatic changes. Spoiler alert, it doesn't end well for anyone. And now, my curious friends, let's look into the far future, the ultimate fate of our solar system, if the sun decided to double in size or mass. First, let's revisit our favorite puffy star scenario. When the sun doubles its diameter without gaining mass, it transforms into what astronomers call a red giant. This is not just a small mood swing. It's the beginning of its stellar death throes. Eventually, it would shed its outer layers into space, creating a beautiful glowing cloud called a planetary nebula. What remains at the center is a tiny, dense white dwarf, an object about the size of Earth, but with half the sun's mass crammed inside. Imagine that, a star that once lit up your days, reduced to a hot, glowing ember floating quietly in space, surrounded by the ghostly remains of its former glory. Poetic, but completely useless for keeping planets warm. But if the sun's mass doubled instead, we enter an entirely different cosmic nightmare. A star with twice the mass of our current sun burns its nuclear fuel far more rapidly, living fast and dying young, a rebellious teenager of the cosmos. Instead of lasting for 10 billion years like our calm sun, this new massive star might last only 1 billion years before running out of hydrogen in its core. When that happens, it swells into a red giant even more massive than before, eventually fusing heavier elements in its core. Depending on its final mass, it could either collapse into a dense white dwarf like before, if below about 8 solar masses, or, if it gains even more mass through mergers or accretion, end its life in a spectacular supernova explosion. Now, that would be a show worth watching, if only from a very, very safe distance. In a supernova, the outer layers are blasted into space at speeds of up to 10,000 kilometers per second, creating shockwaves that trigger the birth of new stars and planets elsewhere in the galaxy. Meanwhile, the core collapses into either a neutron star or, if massive enough, a black hole. Yes, a literal cosmic drain hole from which not even light can escape. But what happens to the rest of the solar system during these dramatic events? For starters, when the sun loses mass by blowing off its outer layers, its gravitational grip weakens. The planets would drift outwards, their orbits expanding. However, if the sun explodes as a supernova, an unlikely fate for our real sun, but possible for more massive stars, the inner planets would be vaporized instantly, while outer planets might be flung out into interstellar space, becoming lonely rogue wanderers between the stars. And if a black hole forms, well, it would continue to hold the remaining planets in orbit, but instead of orbiting a warm, life-giving star, they would circle an invisible abyss of doom. Not exactly the brightest future for any surviving worlds. So, whether our sun decides to bloat up peacefully or go out with a bang, the long-term fate is the same for us. Total extinction on Earth and the end of the solar system as we know it. The universe will continue, of course. Stars will keep forming. Galaxies will keep colliding. Black holes will keep devouring everything unlucky enough to wander too close. And somewhere out there, other curious minds might ask the same questions we do today. But until then, remember, our sun is stable, for now. So, enjoy the warmth, the sunsets, the life it provides. Because in cosmic terms, nothing lasts forever. And if you enjoyed this little journey through the horrifying possibilities of stellar physics with me, Albert Einstein, don't forget to hit that subscribe button, give this video a thumbs up, and share it with your fellow curious minds. After all, knowledge is the only thing that grows when shared, unlike the sun, which just explodes when it gets too big. Thank you for watching, and I'll see you in the next mind-bending episode.